Good day, everyone. We will answer the set of questions in derivative, and I will just explain to you. So the first problem, we have the f of x is equal to 4x to the fifth minus 5x to the fourth power. So we're just gonna, this is power rule, so the power 5, let's multiply it by 4 and then minus it by 1, so that would become 20x to the fourth power, and then the same, so that would be minus 20x cubed. So number 2, we have 4x is equal to 4 of x is equal to the quantity of x to the fourth power plus 33x to the negative 1. So we're just gonna have to do the chain rule of this one. So first is we're gonna put negative 1 and then the inner function, which is the x to the fourth power plus 3x. So negative 1 minus 1, that is negative 2, that's why it's negative 2. And then the derivative of the inner function, x to the fourth power, the x to the fourth power plus 3x, that would be 4x 4x to the 4x cubed plus 3. I'm sorry, there should be 3 there. So next is we have number 2, f of x is equal to e to the x sine x. So the derivative of that is f prime of x is equal to e to the power of x sine x plus e to the x cos x, or ex times the quantity of sine x plus cos x. So number 4, we have 4 f of x is equal to 3x squared times the quantity of x cubed plus 1 to the 7th power. So first, let's write the 3x squared first times the power, bring down the power, which is 7, and then write the inner function x. This is involving the chain rule, so that it would be x cubed plus 1 to the 6th power, because 7 minus 1 is 6, and then the derivative of the inner function inside the parenthesis, which is 3x squared plus the inner function again, x cubed plus 1 to the 7th minus 6x times 6x. Alright, so let's move on to number 5. So the problem in number 5 is we have to derive f of x is equal to cos to the fourth x minus 2x squared. So the derivative is so f prime of x is equal to, bring down the 4 as the base, 4 times the quantity of cos x, that is the inner function, cos x, 4 minus 1, that's why it's 3, and then the derivative of cos x is negative sine x, then that would be minus 4. Next is number 6, we have f of x is equal to x over 1 plus x squared. So the derivative of f of we will use the, that's why f prime of x is equal to the quantity of 1 plus x squared minus x times the quantity of 2x over all over the quantity of 1 plus x squared. So now let's have number 7, f of x is equal to x squared minus 1 over x. So f of x is equal to x minus 1 over x, so the derivative of that is 1 plus 1 over x squared, or 1 plus x to the power of negative 2. So number 8, we have f of x is equal to the quantity of 3x squared times the quantity of x 1/2. So the f of x, that would be 3x 5/2, and then f prime of x, which is the derivative, that would be 3 times 5/2 x to the power of 3/2. And then the final answer of our derivative, that would be f prime of x is equal to 15/2 x to the power of 3/2. So let's proceed to number 9. We have f of x is equal to ln times the quantity of x e to the raised to the power of 7x. So ln AB, that would be equal to ln A plus ln B. That is our formula. So we just need to substitute. So f of x is equal to our ln A, that will be ln x plus ln B, which is 7x. So the answer of that is f prime of x, or the derivative of f of x is equal to 1/x plus 7. So number 10, f of x is equal to 2x to the 4th power plus 3x squared minus 1 all over x squared. So f of x is equal to 2x squared plus 3 minus x to the x squared. So our derivative, f prime of x, is equal to 4x plus 2x to the power of -3. Then our number 11, f of x is equal to the quantity of x cubed times the 5th root of 2 minus x. So our derivative is f prime of x is equal to 3x squared times the quantity of 2 minus x raised to 1/2 plus x cubed times -1/2 times the quantity of 2 minus x raised to the power of -4/5. So next is we have f of x is equal to 2x minus 4 over the square root of x. So f of x is equal to 2x minus, let's just change the 4 over square root of x into 4x raised to the power of -1/2. So it can simplify the whole thing. So that would become f of x is equal to 2x minus 4x raised to -1/2. That is our new equation. Then that is our new equation. Okay. So again, our derivative is f prime of x is equal to 2 plus 2x raised to -3/2, because -1/2 minus 1 is -3/2. So now let's go to number 12. F of x is equal to 4 times the quantity of 3x minus 1 raised to 2 over x squared plus 7x. So since it is division, we're gonna use the formula v du minus u dv over v squared. So that's why we can attain this form: 24 times the quantity of 3x minus 1 times the quantity of x squared plus 7x minus 4 times the quantity of 3x minus 2 squared times 2x plus 7x ln 7 over x squared, the quantity of x squared plus 7x raised to 2. That is our answer. And number 14, we have f of x is equal to the square root of x squared plus 8. So again, this is x squared plus 8. We can change this into a simple form so that we can solve easily. So it can change into f of x is equal to the quantity of x squared plus 8 raised to 1/2. So we will use the chain rule for this. So our f prime of x is equal to copy 1/2 and copy our inner function, which is x squared plus 8, and then 1/2 minus 1, that is negative 1/2, times the derivative of the inner function of which is x squared plus 8 will become 2x. So that's why our answer would be f prime of x is equal to 1/2 times the quantity of x squared plus 8 to the power of negative 1/2 times the quantity of 2x. Now, let's proceed to number 15. So, number 15, f of x is equal to x over the square root of 1 minus the quantity of ln x raised to 2. So our derivative is f prime of x is equal to 1 times the quantity of 1 point 1 times ln x to the second power and to the power of negative 1/2 times the quantity of negative 2 ln x times 1 over x all over the quantity of 1 minus the quantity of ln x squared. So that is our final answer. Then we have number 16. So our number 16, f of x is equal to 6 over the quantity of 3x squared minus pi to the 4th power. So alright, we can change this into simply as form, where we change our denominator, we change it and then combine it with our numerator but make our exponent negative. So that's why f of x is equal to 6 times 3x squared minus pi to the negative 4. So f prime of x, that is equal to the derivative now using the chain rule again, is negative 24 times 3x squared minus pi raised to negative 5 times 6x. So number 17, we have f of x is equal to the quantity of 3x squared minus pi x to the 4th power over 6. So again, we can change this into simply as form, which is now 1 over 6 times the quantity of 3x squared minus pi x to the 4th. And then using the chain rule again, we can attain its derivative. So which is f prime of x is equal to 1 over 6 times 4 times the quantity of 3x squared minus pi x raised to 3, because 4 minus 1 is 3, times the derivative of the inner function, which is 6x minus pi. So number 18, f of x is equal to x over the quantity of x squared plus the square root of 3x to the raised to 5. So we can change this into simplest form, which is x times the quantity of x squared plus the square root of 3x raised to negative 5, and then we can get the derivative, its derivative, which is now 1 times the quantity of x squared plus square root of 3x raised to negative 5 plus x times the quantity of negative 5 times the quantity of x squared plus square root of 3x raised to negative 6 times 2x plus 3 over 2 times the square root of 3x. So we are now in number 19. So in number 19, in lower part, we have the problem f of x is equal to the quantity of x e raised to x raised to pi. So this is quite complicated, no? But we can still follow the chain rule in order for us to solve this. So f prime of x, that would be equal to pi times x e raised to x raised to pi minus 1 times x e raised to x times ex times the quantity of 1 plus x. So our final answer, that would be f prime of x is equal to pi times x e raised to x raised to pi minus 1 times ex times the quantity of 1 plus x, or f prime of x is equal to pi times the quantity of x e raised to x pi minus 1, and then multiplied by the quantity of x e raised to x plus e raised to x. So we are now in number 20. F of x is equal to arctan 2x raised to 10. So our derivative for this is tan 10 arc times the quantity of arctan times 2x raised to 9 multiplied by 1 over 1 plus the quantity of 2x times 2, and then our final answer is f prime of x is equal to 10 arc tan times the quantity of 2x raised to 4 times 2 over 1 plus 4x squared. So we are now in number 21. So our number 21 is f of x is equal to the quantity of e raised to 2x plus e raised to 1/2. So the derivative of that is f prime of x is equal to 1/2 times the quantity of e raised to 2x plus e raised to negative 1/2 times the quantity of 2e raised to 2x. So much for that problem, because it's still different, the same. So let's have another one, this one. So in the problems 40 to 42, find dy over dx. Assume y is a differentiable function of x. So number 40, we have 3y is equal to x e raised to 5y. So we should assume y is a differentiable of x. So 3y prime is equal to e 5y plus 5x e 5y. So 3y prime minus 5x e raised to 5y. So y prime is equal to e 5 raised to 5y. So y prime times the quantity of 2 minus 5x e raised to 5y is equal to e 5y. That's why our y prime is equal to e 5y over 3 minus 5x raised to e 5y. So our 41, xy plus y squared plus x cube is equal to 7. So since we need to assume y is a differentiable function of x, so that's why xy prime plus y plus 2y y prime plus 3x squared is equal to 0. So xy prime plus 2y y prime is equal to negative y minus 3x squared. So y prime times the quantity of x plus 2y is equal to negative y minus 2x squared. So y prime is equal to negative y minus 3x squared over x plus 2y. Alright, so now let's move on to number 42. Sin y over y squared plus 1 is equal to 3x. So the quantity of cos y times the quantity of y squared plus 1 minus the quantity of sin y times the quantity of 2y y prime all over y, the quantity of y squared plus 1 raised to 2 is equal to 3. So y prime times the quantity of y squared plus 1 times cos y minus 2y sin y over the quantity of y squared plus 1 raised to 2 is equal to 3. So it will more, there is more solution to it. So let's continue. Y prime times the quantity of y squared plus 1 cos y minus 2y sin y is equal to 3 times the quantity of y squared plus 1 to the raised to 2. So the answer of this is equal to y prime is equal to 3 times y squared plus 1 raised to 2 over y squared plus 1 times the times cos y minus 2y sin y. Alright, so for number, if f and g are differentiable functions such that f of 2 is equal to 3, f prime of 2 is equal to negative 1, f prime of 3 is equal to 7, g of 2 is equal to negative 5, and prime g prime 2 is equal to 2. Find the numbers indicated in problems 43 to 48. So this is very easy since we just need to substitute the given value. So number 1, for number 43, it says here that the quantity of g minus f prime of 2 is equal to, we just need to substitute. So what is our g of 2? That is 2 minus our f prime of 2, that is f prime of 2, that is 1, negative 1. So 2 minus negative 1 is 3. So the same with all the problems there, we just need to substitute. So number 44, f of g prime of 2 is equal to f prime g plus f g prime. So that would be f prime of 2 g of 2 plus f of 2 times g prime of 2. So that would be equal to, we just need to substitute. So we will now have a value of negative 1 times negative 5 plus 3 times 2. So that is 5 plus 6 is equal to 11. So that is the answer. And number 45, I mean, f over g prime of 2 is equal to f prime g minus f g prime is equal to all over g squared. So we will use v du over u dv v squared in this kind of form. So that would be f prime of 2 g of 2 is minus f of 2 g prime of 2 over g of 2. So to substitute the value, we have now the given negative 1 times negative 5 minus 3 times 2 over negative 5 times 2. So that is 5 minus 6 over 25. So that is equal to negative 1 over 25. So for the 46, here 46, f5, the quantity of 5f plus 3g prime of 2. So again, that is 5f prime plus 3g prime. We just need to substitute the given value. So 5 times negative 1 plus 3 times 2 is equal to negative 5 plus 6. So that is equal to 1. And then we have our 47, the quantity of f of f prime of 2. So that would be equal to f of x. It's like a composite functions. So we just need to substitute the value again. So f of prime of f of 2 times f prime of 2. So that is f prime of 3 times negative 1. So that is 7 times negative 1 is equal to negative 7. So number 48, the quantity of f over f plus g prime of 2. So that would be equal to substitute the value. So we have negative 1 times negative 2 minus 3 times 1 all over negative 2 times 2. So that is 2 minus 2 is equal over 4. So that is negative 1/4. So now let's have another. Let's try this one. Find the derivative of each functions. Okay, so number 1, f of x is equal to 3x squared plus 5x minus 2. This is very easy differentiation, okay? Since we just multiplied 3 times 2, the base and the power, so that is 6x plus the derivative of 5x minus 2. 2 will become 0, 5x will become 5, so that is 6x plus 5. Next is number 2, g of x is equal to negative 4x to the 4th plus 5x cube minus 2x plus 3, so that will become same problem, so that will become g prime of x is equal to negative 16x cube plus 15x squared minus 2. That would be the answer, and all the questions are just the same. So let's try this one. The number 6, f of x is equal to x squared minus 5x minus 24 over x minus 8. So when you see this kind of problem, it has a you can make it into simplest form, which is you can factor this x squared minus 5x minus 24 into the quantity of x minus 8 times the quantity of x plus 3 all over x minus 8. So we can see a common x minus 8, we can cancel that out, so our function would become f of x is equal to x plus 3. So the derivative of x plus 3 is now 1, so that is the answer. Yeah, so it's all quite the same from the other, no? It's all the same. So let's find another problem that it's not the same. So this is still the same, but let's try number 5. G of x is equal to sine squared times the quantity of 3x squared. So g prime of x is equal to let's use the chain rule of this. So let's copy 2 and then sine times what is the copy the inner function 3x squared. So what is the derivative of sine? It is cos, and then the derivative of the inner function 3x squared, put it there. So that's why the answer of it is g prime of x is equal to 12x sine times the quantity of 3x squared times cos times the quantity of 3x squared. So still the same. Now let's find another one. Alright, so that is all. That are some of the problems that we will encounter in derivatives. We'll encounter with that we will encounter the derivatives of the trigonometric, the basic one, and what's the most important is that we will know rules in derivatives, the 8 basic rules, the rules in differentiation of the trigonometric functions, and then we know how to follow the rules. And I suggest that you should also make the you should also put the formula, because there is a formula in your head, so that you will know or how to differentiate it. So thank you very much for watching, and I hope that you've learned a lot from that discussion. Thank you so much for watching.